Oh, all right. Let's continue working on problem number 3 from this worksheet here. What f value from the table do you need? Number 3. You've been asked to compare 5 groups simultaneously via f-test and test the null hypothesis at the 0.05 level. Okay, that's all well and good. 5 groups, that means k equals 5. We also need to know what n subtote is. In subtote, we simply add the number of cases in each group together. As you can see from the sheet, from this third problem, group 1 equals 5, group 2 equals 4 cases, group 3 equals 4 cases, group 4 equals 6 cases, and group 5 equals 7 cases. 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 6 is 8. 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 6 is 19, 19 plus 7 is 26. So n subtote equals 26. Degrees of freedom for between slash treat is k minus 1 or 5 minus 1, which is 4. And then degrees of freedom within is n subtote, in this case 26, minus k, which is 5. 26 minus 5 is 21. So in order to find, and it's right there on the sheet, but we're also testing the null hypothesis at the 0.05 level. So let's consult the F table. Degrees of freedom numerator is 4. Degrees of freedom denominator is 21. 4, 21, 4, 21. Degrees of freedom numerator is 4. Degrees of freedom denominator is 21. We are testing the hypothesis at the 0.05 level, which means our F value, we need to pull the light-faced, as opposed to the bold-faced, the light-faced value, 2.84. That is our critical F value. F equals 2.84. And what does that number mean? That number is the maximum amount of between-group variance we could expect to occur by chance alone, given certain conditions. And in this case, those conditions are 5 groups that we're comparing, 26 cases total, and an alpha level of 0.05. Okay, let's do the last one, number 4. You've been asked to compare 4 groups simultaneously via an f-test and test the null hypothesis at the 0.01 level. All right, so 4 groups, and we're being asked to test the hypothesis at the 0.01 level. So k equals 4. N subtote is simply adding the number of cases together in all 4 groups. In this case, this last example, group 1 equals 7, group 2 equals 7, group 3 equals 4, group 4 equals 9. 7 plus 7 is 14, 14 plus 6 is 20, 20 plus 9 is 29. So n subtote equals 29. So k equals 4, 4 groups, n subtote equals 29. The total number of cases involved in the analysis is 29. Degrees of freedom between is k minus 1, or in this case 4 minus 1, or 3. Degrees of freedom within equals n subtote minus k, or in this case 29 minus k, or 29 minus 4, which is 25. And we are testing the null hypothesis at the 0.01 level. So again, I'm consulting the table. I've turned it landscaped. Degrees of freedom in the numerator is 3. Degrees of freedom in the denominator is 25. And we are testing the hypothesis at the 0.01 level. So we need the bold-faced value, which according to the table is 4.68. What does that value mean? That value is the maximum amount of between-group variance we could expect to occur by chance alone, given certain conditions. And what are those conditions? Those conditions are, in this case, 4 groups and a total of 29 cases and a 0.01 critical level. Okay? 4.68. Our tabled F value is 4.68. And that value is the maximum amount of between-group variance we could expect to occur by chance alone, given certain conditions. And those conditions in this case are 4 groups, a total of 29 cases, and an alpha level or critical region of 0.01.